Start recording. Okay, let us start. Now look over here. So let us go. Aircraft wind problem. So like as whatever we have done till now in the class also, like we try to do. So let's suppose if you have an aeroplane, right or not? Okay, I can't draw the aeroplane perfectly. Okay, it is moving at some kind of velocity v. Okay, now this aeroplane is moving in the wind. Okay, is moving with respect to the, the aeroplane will fly upwards, so that means what, it will move with respect to the wind. If the aeroplane has velocity v and wind has also some velocity v, okay, now we want to find the velocity of this aeroplane required with respect to the ground from a frame of reference, because the engines will work with respect to ground. Okay, so we want the velocity of this aeroplane. This is ground, this is my aeroplane. I denote velocity of aeroplane as what? Velocity of aeroplane as v. Got it or not? Now look over here. This aeroplane will have velocity with respect to wind. Yes or no? Because if the wind is high, you will have to move faster. Then this wind will have some velocity with respect to ground. Okay, so this wind has some velocity with respect to ground. Then what is going to happen? The aeroplane will have some velocity with respect to ground also. So I can write the relation velocity of aeroplane with respect to ground is nothing but these two vectors. This is what velocity of wind with respect to ground. This is velocity of aeroplane with respect to wind. This is velocity of aeroplane with respect to ground. So velocity of aeroplane with respect to ground, head matching velocity of aeroplane with respect to wind plus velocity of wind with respect to ground. Yes or no? Are you able to get me or not? I have done this kind of thing. Yes or no?
Yes, sir.
Guys, you'll have to say me yes or no. Okay. Now, this means what? Velocity of aeroplane is nothing but velocity of aeroplane with respect to wind plus velocity of wind. Why? Because velocity of ground is nothing but it is equal to 0. One thing you should remember always, when I write v of a with respect to g, this particular term has also a meaning that I can write this as velocity of aeroplane minus velocity of ground. Now that is why velocity of aeroplane minus what is the velocity of ground? 0. That is why I am able to write velocity of aeroplane with respect to ground as velocity of aeroplane. Are you able to get me or not? Yes or no? This particular analogy?
Yes.
Okay. Now, what we are going to do, we are going to utilize this and we'll solve some numericals, but a little bit later. Next type we'll do, and that is called as rain and man concept if rain is falling vertically downward. So we are going to take three possible cases for the particular rain and man. Okay. Now, what we are considering that, let's suppose a man is walking on a horizontal path. Okay. And I'm representing this as horizontal. Okay. It's trying to join. Okay. Where is the Sparsa? We do not know. Okay. Now this is what? My vertical path. Okay. So you have vertical, you have horizontal. Now, man is walking horizontally, got it or not? So I'm representing the velocity of man along the horizontal path using this way. Okay. Wait, I'll denote it by black and thick line. Okay. So this is in this particular direction we have velocity of man. Got it or not? Okay. Now rain is falling vertically downwards. So that is a very simple case. You can try to understand rain is falling vertically downwards over here. Okay. I'll not denote it by down. I'll denote it by up. Okay. So this is the velocity of rain. Now, if man is moving towards this side, rain is falling downwards. What you are going to observe that according to this particular thing, I can make this particular velocity of rain over here. I can draw the resultant like this way. What I told that, let's suppose if this rain is falling downwards, what is going to happen if velocity of man is 0, then velocity of rain will not change with respect to man. This is the concept. What? That Let's suppose if the rain is falling vertically downward, man is moving towards this side. Now man is stationary. What is going to happen? The rain will still continuously fall vertically downwards. Okay. Now if the man has started to move forward with some kind of velocity v, actually according to this particular graph, this should turn towards this side. Means the resultant should come over here. But what I'm saying that this rain has started hitting the man towards this side. Okay. Means if the man has some velocity, if man has, second case, this is the first case, this is second, if man has some velocity, rain starts to hit man, starts to hit the man at angle theta with respect to the vertical, yes or no? So this is the velocity of rain with respect to man when the particular man starts to move with some velocity over here. Now you know that I can resolve over here, I can bring this particular velocity of rain with respect to man, velocity of rain over here. Okay, and we know that this velocity of man, I can bring it over here according to the parallel component rule. Okay, so this is what velocity of man. From this, what you got as answer, that velocity of rain with respect to man is nothing but it is equal to velocity of rain minus velocity of man. Look over here, tail is matching, that's why velocity of rain is positive. Head tail is matching, therefore velocity of man is negative. So you got one relation that if the rain is falling vertically downwards, if man velocity is 0, rain will still continuously fall downwards. But if the man starts to move at some kind of angle theta, what will happen? The rain will start hitting the particular person at some kind of angle theta. So what man will have to do? Man will have to keep his umbrella like this way. Okay, man will have to keep this umbrella like this way so as to oppose the rain. Remember that if someone asks you what is the direction of umbrella, direction of umbrella, it should be equal to direction of rain with respect to man. Got it or not? So what is the direction of umbrella? It is the direction of rain with respect to man. Now till now we have done. Okay, now I will apply this. This was a simple concept. Okay, but we can apply this and we can get the answers easily. But what if happens like if the rain starts to hit the man from the back? The question is, instead of following this particular kind of downward path, what has happened? The rain has started to hit the man with backside. Now look over here. Here man is stationary. The velocity of man is how much? It is equal to 0. But what is happening over here, guys? What is happening? Purely try to see this. That this is the vertical path. Yes or no? This is vertical, and this is my horizontal. This is horizontal. Sorry. And this is my vertical. Got it or not? Now what has happened? The rain is hitting the man from the back. Okay, the rain particularly it is hitting the man from the back side. Yes or no? Now when the rain is hitting, it will hit the particular man by making some angle phi or not? Tell me yes or no? Hitesh, Radha, Ankit, yes or no? Okay. Now you try to understand, if the man velocity is 0, what is going to happen? Rain will still hit the particular person at angle phi. Got it or not? Or yes or no? Ankit, Hitesh, everyone, Parinita, Sanjana, Sneha, yes or no? The point is simple. What I told Afan, Nisant, where is Nisant? Nisant is here now? Okay. So now look over here. What I'm saying is, if the rain is hitting from the back and man is also not moving, he will keep his umbrella in the direction of phi. And what will happen? He will be able to stop the rain on himself. Got it or not? Now, the particular question comes. Let's suppose if the man starts to move with some kind of velocity towards right. So this is the velocity of man towards which side? Right side. And this was the direction of rain or not? Tell me so no, rain is hitting from the back side. The question is, what will happen after that? Where will be the, see, original direction of rain is what? Towards this way or not? Making angle phi, yes or no? Everyone? Guys, yes or no? The question is simple. If the man starts to move with velocity v towards the right side, Hitesh, are you here or not? तो बोलो भाई अंकित तुम लोग शांत हो यार. क्वेश्चन है, if the man is moving towards right side with velocity v, original direction of rain is what? This was the original direction of rain. Still original direction of rain is what? This one. Means rain is still making how much angle with respect to the vertical? It is making angle fine. This was the original direction of rain. But when man starts to move with in this particular direction, what is going to happen? Try to think. So, have you done this kind of experiments with yourself or not? Okay, so you guys are still newborn. I have done this experiment. Okay, so I was driving on a bike. Okay, so let's suppose if rain was hitting me from back, what I observed that when I was moving faster, what was happening? The rain started suddenly to become vertical. The question was why? So actually wind was making the rain to move towards this side. Okay, so it was making particular angle phi with the vertical. Now when I have started moving in the similar direction of the wind, what will happen? You know now, relative velocity between them. You try to understand. Arey yaar, you guys are nanna munna bachchas yaar. Means whatever I do, you will not reply. So look over here. This is my car. Again, Sundar Kanya. Hitesh is driving this car to meet his girlfriend, far more girlfriend. Okay, these two cars are there. Okay, now look over. This is the velocity of Hitesh. This is the velocity of Sundar Kanya. Now you know that the relative velocity between Hitesh and Sundar Kanya is going to be equal to how much? Zero. If they have the similar velocity in the forward direction or not? Yes or no, guys? Yes or no? Simple. So why it is happening? It is happening due to the relative velocity of Hitesh with respect to. Wait. Guys, are you here? Is I audible? Okay. A little bit. I have to purchase that power bank app that is going to cost me 1600. So do not take tension. Wait. Is it here in the screen? Save. So I'll purchase this month, I think, and then we put that power bank. Okay. Is it visible or not? Screen is visible. No mirroring is not there. No. Okay. Now look over. Let me start. Now, so now look over here. What I said, if the two objects are moving in similar direction, what you will find out that the velocity of this Hitesh with respect to Sundar Kanya is equal to how much? Zero. Similar thing is happening. Rain has actually one velocity component towards the horizontal, one velocity component towards the vertical. Man has velocity m towards the horizontal only. So what is going to happen? These two horizontal component velocities are going to be equal to what? Zero. If the man starts to run, if it tries to match the velocity of rain along the horizontal, let's suppose if velocity of man becomes velocity of rain with respect velocity of rain cos phi, sorry, sin phi here. So what will happen? At that case, what is going to happen? The particular horizontal component velocity means rain will not hit the person along the horizontal. It will try to become purely vertical. Got it or not? Because the relative velocity of man with respect to the rain's relative velocity along the horizontal has become how much? Zero. Got it or not? So that is why you try to observe. What I'm saying is, if the man has started to move with some kind of velocity v of m towards the right side, so what is going to happen is, this is the velocity of rain along the original path. Okay, what will happen if the man starts to move? Again, I'm saying, if the man starts to move towards right, this is the original velocity of rain. What will happen? Rain will start shifting towards the vertical, because what is happening due to increase in the velocity? I'll write this because you guys are not aware of this. Due to increase in the velocity of man along the direction of horizontal component of rain, and due to this, what happens? Velocity of rain with respect to the man along the horizontal approaches zero. Yes or no, everyone? Guys, are you able to understand me or not? It will know any kind of doubt. Any kind of doubt you can ask me. Is there any kind of doubt? No, no. Okay. So now look over here. What I said, as the man velocity is increasing towards the right side along the horizontal component of this rain, original direction of rain along the horizontal component. So therefore, due to the relative velocity concept, man's velocity, and due to the matching of these two horizontal component of rain and man velocity, what is happening? Velocity of rain with respect to man along the horizontal is becoming zero. So if it becomes zero, what will happen? The original velocity of rain, what it will feel to the man? That the velocity of rain now is changing the direction. In which direction it will change? The point is, it will change in the direction, since horizontal component is becoming zero. So where the original velocity of, where will be the velocity of rain with respect to man? It will shift towards the vertical. Got it or not? Where the particular, look over here, what is happening? Velocity of rain with respect to man, horizontal, approaches where? Approaches zero. So what will happen? Due to this, velocity of rain with respect to man will try to become vertical. Got it or not? Yes or no? Are you able to get me or not? So these are the properties. So here what has happened? The velocity of rain with respect to man started to become vertical. So therefore now, where the particular rain is hitting to the particular person, it is hitting at some kind of angle theta made with the vertical. This is the angle theta made with the, this is my vertical, this is the angle theta made with the vertical. Initially it was hitting as how much angle? It was hitting at angle phi. Now it is hitting at angle theta. Got it or not? So at phi it was the original velocity of rain. At theta it is the velocity of, this is velocity of rain with respect to man when man starts to move. Are you able to get me or not? Yes or no, guys? Okay, now moving to next point. Now, when it happens that the man has a very total amount of, means if the total velocity of man becomes such that, if the, here what has happened, velocity of man has become equal to what? Velocity of rain. Now look over here, this is the angle phi or not? So here it will be velocity of rain sine phi or not? Tell me so no. So if velocity of man becomes equal to what? Velocity of rain, wait, velocity of rain into sine phi, what will happen? Velocity of rain with respect to man in a horizontal direction is going to be equal to how much? Zero. If it becomes zero, then where will be the particular rain will be hitting to the person? It will be hitting the person purely vertical. Remember that this is the JEE question it is, okay, and not normal. It is a JEE advanced question, okay. What they ask, that if the horizontal component of original rain velocity hitting from back becomes similar with the man velocity, where will be the rain hitting? So there were four options. Where will be the rain hitting? It will be hitting purely vertical. Got it or not? Velocity of rain with respect to man will become purely vertical. Are you able to get me or not? Yes or no, everyone? Got it? Yes or no? Easy? Radha, Sneha, Sparsa. Okay. Afar, Nissan, Parinita. Okay. So these are that's why I told today's class is going to be very, very important for you guys. Okay. So I was making you try to see I have made so many notes now for you guys that it's not going to be over. Like I have the pending syllabus. Now, next thing is again now the further man is increasing its velocity. Now, if it further increases its velocity, what will happen? You try to see. Next case, you try to understand this. See, first case here, what has happened? Like, let's suppose this particular car was over here at point A. Okay, so at point A, relative velocity between Hitesh and Sundarkanya is going to be how much? Velocity of Hitesh minus velocity of Sundarkanya. At this point B, when they were at the same speed, velocity of Hitesh with respect to Sundarkanya has become 0. Now, consider at point C, Maghdum Khan, why he is coming? Or not allowed. Maghdum, that guy, na, uh, which sits with Yasin, yes or no, Afan? Yeah, he let him prepare for board, man. He can't handle this. Okay. Now look over here. Now, at point C, what is going to happen? Velocity of Hitesh with respect to Sundar Kanya. Well, Sundar Kanya will move faster. Okay, I'm considering that Sundar Kanya has again increased the velocity. So what will happen? Velocity of Hitesh, if I write velocity of Hitesh minus Sundar Kanya, this will be negative or not? Tell me yes or no. Relative velocity will become negative or not? Because what has happened? The velocity of Sundar Kanya has been increased over here. Are you able to get me or not? Yes or no? Guys, yes or no? So if let's suppose the further velocity increases, what will happen over here? The rain will start hitting in the opposite direction of the man. Got it or not? So you try to see here the umbrella was making angle phi, here the umbrella is making angle theta, here the umbrella is making angle 0, here the umbrella is making angle theta, but in the opposite direction. Got it or not? Yes or no? So now look over here, this is the last case. Okay, this is the last case. This is the velocity of like sorry, this is vertical. Now, where was the original direction of velocity of rain? Original direction of velocity of rain was this. Still, okay, where it was making angle phi with the vertical. Got it or not? Now, as the further increase in the man's velocity, what has happened? That your rain has started hitting the particular person at this particular angle. Okay, means this is the velocity. Okay, I need to choose another color. Yellow color is good or not? Yeah, it is visible. So this is velocity of rain with respect to man when the person starts to move very, very much faster. Got it or not? Yes or no? Now, this is hitting at angle theta. The question is simple. Sorry, this is hitting at angle theta. So I'm writing that this is hitting at angle theta. The question is simple. What is your work? Now I have discussed all the cases from here. Okay. What is your work actually? You have to find the equations for all of these possible cases of this theta. Okay. Means at least for two cases. Here you know theta is 0. Here theta is equal to 5. The direction of umbrella you can calculate. But here I want at this case, what is the equation of theta? What is the direction in which umbrella should be kept with respect to the vertical? You have to calculate and you have to show me tomorrow in your papers, those who are attending the classes. Got it or not? Yes or no? Will you do it for me? Okay. Now, based upon this, what we are going to do, what we are like, these were the three cases or four cases when the particular rain starts to hit the man at back. Okay. I'm just taking the class. Can I just call it later after 10:30? Okay. Okay. See guys, see my dedication. Means I am leaving the calls of very important person of my life, but still I am taking the classes. Who will teach like this? Okay, moving to next point. Okay, so you have to do what you have to do. You have to write the equations and complete it and show me tomorrow. Okay. Based upon this, we'll try to solve one question. What is that question? Look over here. A man is walking due east with 3 km per hour and finds that rain is hitting him vertically at the rate of 3 km per hour. Okay. Find the actual speed and direction of rain with respect to ground. Find out. Okay, अंकित मैं छोटे छोटे चीजों से स्टार्ट करूंगा. अंकित, यस और नो, थोड़ा आवाज तेज करो यार, तुम एकदम से साइलेंट हो गए हो. चलो ना लोगों बोलिए, बताओ. सबसे पहली बात, यहाँ पे वेलोसिटी, यहाँ पे मैन का तो वेलोसिटी दिया हुआ है. मैन का वेलोसिटी किसके रिस्पेक्ट में दिया हुआ है? रेन के रिस्पेक्ट में. ग्राउंड के रेस्पेक्ट में. यहाँ पे कुछ लिखा हुआ है क्या कि मैन इज मूविंग इन ट्रक, मैन इज मूविंग इन क्लाउड्स? अगर रेन के रेस्पेक्ट में लिखेगा तो मैन को क्लाउड्स पे दौड़ना होगा ना. तुम तो ग्राउंड पे दौड़ रहे हो, है ना. सो यहाँ पे क्या दिया हुआ है? द मैन इज वॉकिंग ड्यू ईस्ट. इसका मतलब क्या हुआ कि मैन, वेलोसिटी ऑफ मैन विद रिस्पेक्ट टू ग्राउंड इज गिवन, दैट इज इक्वल टू हाउ मच? 3 किलोमीटर पर आवर. गॉट इट और नॉट? गॉट इट अंकित? ओके निशांत, स्टार्ट हो जाओ. Now, after that, look over here. Read the next line. Founds that rain is hitting him vertically at the rate of 3 km per hour. Now, what you found from here to here? Can you explain me, Nishant? What is given? Do it fast, Nishant. I want the answers. Yeah. So what does the line means? The rain is hitting him vertically. So what is given? It is the velocity of rain with respect to what? Why and how? And rain is hitting him. Here it has asked rain with respect to ground, so you have told velocity of rain with respect to man. I'll kill you, Nisa. Now look over here. What is given over here? Will founds that rain is hitting him vertically. Now look over here. You try to understand what is written. Rain is hitting him. It is written. Okay. It is not told that rain is falling downwards. It is told rain is hitting him. That means what? What is given? Velocity of rain with respect to man is given. So velocity of rain with respect to man, that is equal to how much? 3 km per hour. Again, what is has been asked? Find the velocity of rain with respect to ground. Now look over here. Here we formed the equation. What was that equation? That velocity of rain with respect to man is equal to velocity of rain minus velocity of man. So now look over here. Apply this formula. Velocity of rain with respect to man is equal to velocity of rain with respect to ground minus velocity of man with respect to ground. So velocity of rain with respect to man is given or not? Okay. Okay, now I will catch. Sneha? Sneha? She slept. Sneha slept. Radha? Switch on your mic. Radha, hello? Yes, sir. Now, tell me, Radha, can we directly put over here 3 and 3? No, correct. Why? Because these are vector addition. So, here it is asked velocity of rain with respect to ground. So, what you will get? Velocity of rain with respect to ground is equal to how much? It is equal to velocity of rain with respect to man minus plus velocity of man with respect to ground. Okay. Now it has told what? Find the actual speed and the direction of rain with respect to ground. Okay. So first we'll try to calculate the speed. So what that will be? It will be equal to modulus of velocity of rain with respect to ground. That is equal to root over what? Velocity of rain with respect to man, modulus square, plus velocity of man with respect to ground, modulus square, plus twice velocity of rain with respect to man, velocity of man with respect to ground into what? Cos theta. It is एंगल कैसे निकालोगे? ये थीटा कैसे निकलेगा? कितना आएगा वैल्यू? 45 degree. Got it. I have caught this now. See this guy. Silly mistake. Where he did silly mistake? Look over here. I have written cos theta. Na? So this angle theta is of which quantities? Yeah. So now, see, this is my velocity of man. This is the velocity of rain. So what is the angle? 90 degree. Yes or no? So you told me 45 degree. It is here. Cos theta is what you did. This direction is totally different. I didn't have talked about this direction till now. Here now, guys, this is the biggest confusion. You try to understand. Here in the direction, it is asking different angle. Here, if you write this equation, that means what? What is this angle theta? This is the angle between which two vectors? Angle between velocity of rain with respect to man and the velocity of man with respect to ground. Got it or not? So this is angle between velocity of rain with respect to man and velocity of ground with respect to man. What is that angle? 90 degree. So cos 90 is going to be how much? 0. So therefore velocity of rain with respect to ground is nothing but it is equal to root over velocity of rain with respect to man square plus velocity of man with respect to ground modulus square. That is equal to how much? Root over 3 square plus 3 square. That is equal to what? 9 plus 9, which is equal to root over 18 meter. Okay, kilometer per hour. Got it or not? Everyone, yes or no? Are you able to get me or not? So, are you able to observe Hitesh? Now got or not? Tell me. So, sometimes. Uh-huh. Okay. But do not do these silly mistakes. Okay. This is the biggest point. This theta is what? This theta is the angle between these two vector quantities. It is not the angle between the rain, okay, and the vertical or whatever it is. Okay. Now, what it is asking, the direction of rain with respect to ground, it is asking. That is the biggest question. Now, where will see this is the velocity of rain with respect to man or not? Now, where the if I just make it downwards, this will be the original velocity of rain with respect to man. This is the velocity of man. Where should be the rain falling down over here? Tell me, everyone. See, velocity of rain with respect to man, it is what? It is the resultant of, or you can say it is a kind of resultant of velocity of rain and velocity of man or not? Tell me yes or no. Yes or no? So where this should be drawn? Hmm? Towards which direction? Towards southwest. Confirm. Yes, if I draw, look over here, if I can draw the velocity of rain along this side, if I draw the velocity of rain along this side, this is the phi angle between man and rain. Okay. For that, the resultant of velocity of rain with respect to man, I will get the vertical or not, everyone. Yes or no? Are you able to get me or not? Huh? See, although you try to understand, one thing is there, two vector quantities, vector A, vector B is there. Okay. Now, the resultant will lie in between it or not. Tell me yes or no. It will make some angle alpha with the A and it will make some beta with the B. Okay, that is 100% sure. So this is your this is your rain falling over. This was the man velocity of man. This is my resultant velocity of rain with respect to man. So where the rain should fall? The rain should fall over here or not? Tell me yes or no. So rain if fall towards this side, what will happen? you will get the velocity of rain with respect to man, this kind of resultant. Are you able to get me or not? Okay. So that is the biggest point. Got it or not, everyone? Yes or no? So now look over here. What it is asking? It is asking find the angle made with the rain with respect to the ground. So which angle it is asking? It is asking this angle. So you will extend this rain towards this side. Okay. This is the actual direction of rain, velocity of rain in this frame, and this is the angle theta which it is asking. Got it or not? So how to calculate? Simple. This is my velocity. I'll take this velocity of rain, parallel component over here. This is velocity of rain with respect to man. So what is going to happen? Tan theta, I can write. Tan theta is equal to velocity of rain with respect to man divided by velocity of ground. Velocity of man with respect to ground. Right or not? The standard is what? Perpendicular divided by this base. This is going to be equal to how much, guys? This is nothing but it is equal to 3 by 3. Do not call this as theta. You guys will get confused. Okay, call this as alpha or something like that. Okay, I'm calling this as alpha. So tan alpha is equal to what? B of Rm, rain with respect to man divided by velocity of man with respect to ground, that is equal to 3 by 3. So alpha becomes how much? 45 degree. So velocity of rain should make 45 degree with the vertical also, 45 degree with the horizontal also. If someone asks you what is the equation of velocity of rain, vector equation, it will be what? It will be equal to what should be the velocity of rain with respect, like what will be the equation for it? Tell me. Okay, so I will give you this as a question. Write the vector equation of velocity of rain. Got it or not? Are you able to get me or not? Yes or no? Hitesh, Nishant, are you able to get me? Yasmin, Radha, are you able to get me? Pranita, Afan, okay or not? So these are the properties which you need to follow over here. Okay. Now, third case of the rain, I'll discuss today only. Third case of the rain. Okay. Now, let's suppose rain was falling in such a way where it was making some kind of angle theta with the vertical. Okay. So it is a third case. What is happening over here? That first rain is falling vertically. Sorry, it is falling by making angle theta with the vertical. Okay, and also man is moving with some velocity over here. Velocity of man is there. Got it or not? The point is simple. The point is very much simple. Does suit the person umbrella keep his keep the umbrella at angle theta or keep the umbrella at angle phi? The question is that. It is Yasmin, निशांत, राधा, स्नेहा, अंकित, बताओ कुछ. It should be a straight on, huh? Acha, look over here. Again, you guys are confused. There are three terms over here: velocity of rain with respect to man, velocity of rain, velocity of man. Now, remember this always. Always, I am saying if velocity of man is equal to 0, then the rain will hit. It will hit if, remember this concept, guys. If velocity of man is 0, then the rain will hit at its own direction with respect to man. Look over here. Here, the rain has this particular direction, got it or not, with respect to the vertical. So this person, if this person velocity is going to be 0, if this velocity of man is going to be 0, then if he holds the umbrella at angle theta, what will happen? He will be able to protect himself from the rain. But the question was, he was not stationary. He was moving with some kind of velocity. So let's suppose if it has a velocity v, velocity of man has some kind of velocity v, what is going to happen? Then what will, if, now second case, if velocity of man is not equal to 0, then you need to consider the rain will not hit at its original direction. Remember this, if the velocity of man is not equal to 0, the rain is never ever going to hit the man at the original direction. So where it is going to hit? It is going to hit at the direction of velocity of rain with respect to man. Got it or not? Where it will hit on the direction of velocity of rain with respect to man. Are you able to get me or not? Yes or no? Is this correct? Hmm? Do not do this kind of silly mistakes. Okay. So where the person, if the man has velocity, this particular angle theta is incorrect. Okay. Actually, if rain is falling vertically with making angle theta with the vertical, the particular man will have to hold the umbrella with respect to phi angle. I do not know what this phi is. If it has some velocity, some positive velocity towards the right side. So we'll calculate this phi. How to calculate? Simple. You will apply this triangle law. What is that? So you know that this is my vertical. Okay. So this is my vertical component. Right or not? Now, rain was making some kind of angle theta with the vertical. So this was the velocity of rain itself. What it was doing? It was making some kind of angle theta with the vertical. Okay. So this was the velocity of rain. Now man was moving towards right, so I can take the opposite component of it to make like right way velocity of man negative. So what I did, I took the opposite component and I wrote it as what? Okay, and try it in yellow. So this is velocity of man, negative velocity of man. Now, got it or not? Now you know that the rain will not hit, if the man has velocity, the rain will not hit at same angle. It will hit at some phi angle. So this is the velocity of rain with respect to man. Let's suppose this is the velocity of rain with respect to man, and which is making some kind of angle phi over here. Got it or not? So if this is phi, what will happen? The rain will also make, the rain with respect to man will make how much angle? Phi with respect to vertical. Got it or not? You can write the equation. Velocity of rain with respect to man is nothing but it is equal to velocity of rain minus velocity of man. Are you able to get me or not? Yes or no? Are you able to get me or not? Got it or not? Okay. So here you try to understand. If someone asks you that here it is totally different. Here it is not a simple case to solve. Okay. Here till now you have discussed, first case was very simple. You discussed the formula for very simple case theta, right or not? You calculated the answer in a very simple way. If you hold the umbrella at angle theta, no rain is going to hit. But in these kind of cases here, you have to hold the umbrella at phi. The question is simple. The question is, what is this phi? What is this phi angle? Okay, so you have to calculate this phi angle. Now how to calculate? Simple. Can you do it logically? Yes, I can do it logically. I can create one triangle over here, right angle triangle. Got it or not? Now based upon that, can you do it or not? Or I'll have to do. Simple now. See this. Okay. I'll do it guys. I'll do it. I'll do it for you. I have already done, but you might have forgotten. This is similar to the case of projection and all. Okay. Now look over here. See this. This okay. Black. This is angle phi. This is magnitude of velocity of rain with respect to man. This is velocity of rain. This is velocity of from here to here. Okay. From here to here, velocity of man. Right or not? So this length will be what? This angle is how much? Theta. So this will be what? VR sine theta. This is going to be what? VR cos theta. Well, look at this trick. Okay, magnitude of VR cos theta. VRM will also have one component along this side, that will be velocity of rain with respect to man. Sorry. cos phi. Okay, cos phi. So what you got as a relation, that v of rain with respect to man cos phi. Okay, okay, so this is plus velocity of rain with respect to cos theta. This is your vertical component. Okay, now in the horizontal component, what this will be, velocity of man plus velocity of rain sine phi. Got it or not? This is your what? Sorry, horizontal component. Okay. Now, velocity. What is the velocity of rain? This particular rain with respect to man will also have sub component over here. What that component will be? This will be velocity of rain with respect to man into sine phi. Got it or not? Now, this whole length and this whole length are parallel to each other. So therefore, what you got as a relation, velocity of rain with respect to man sine phi is going to be equal to velocity of man plus velocity of rain into sine theta. Sorry, this is theta. Okay, are you able to get me or not? So this is the main relation. Okay, now remember that never ever take these two as similar. This, if they are falling in the same direction, that doesn't mean that this and this are equal to each other. Got it or not? Okay, are you able to get me or not? Uh, but they will be equal. They will be equal also. You can write. Why we can write? So look over here. Sorry. Here velocity of man is there or not? Rain with respect to man is there. It has one component, velocity of rain with respect to man cos phi over here. This rain is falling in different direction. It has one component, velocity of rain cos theta over here. Now, since these two vectors are totally different and we are trying to compare, so therefore we can write velocity of rain with respect to man cos phi as equal to what? Velocity of rain cos theta. Got it or not? Sorry, cos theta. So therefore, you can take the ratio over here, but it will become tan phi is going to be equal to velocity of man plus velocity of rain sine theta divided by velocity of rain cos theta. You have already done this, yes or no? In terms of what you have done, yes or no? Are you able to get me or not? No problem till now. Afan, Hitesh, Nishant, Parinida, Radha, Sanjana, Sneha, Yasmin, okay? It might be hard, little bit it might be hard. I'm not saying it is not hard, but this is the original concept. If question comes from here, now you can solve properly. We have done all the three possible cases. Okay, no, I can't do this in class because if I do, people will die in my classes. Okay, if you die over here, I think it is not a big problem. Okay, so your whole relative velocity parts are completed. Now I told already 6 parts are there. Okay, so in class I have done only 3 parts. Here I have done 3 different parts. Okay, so first downward case, second hitting from back and all. After that, a little bit of discussion on that one problem, and then we have done this particular part, third part. Last part is left. Last part is the relative velocity between the projectile. That I will do in the class. That will be very simple one. But here what I will do, I'll do the relative velocity between projectile when itself the, let's suppose there is one kind of question. Okay, what it says, like, let's suppose if a truck is over here, from here you are throwing one projectile. If another truck is there which is also moving with velocity v, this one is also moving with velocity v. The question is, with what velocity, with what relative velocity they should move so that this particular projectile comes down in this. Okay, so this kind of questions we will try to do. Okay, so there are some things which we need to do. Okay, but before that, before leaving you guys, I'll do one problem, one good problem. Try to do this problem. Okay, what it is saying, two ships A and B 10 kilometers apart on a line running south to north. Okay, two ships A and B are 10 kilometers apart on a line running south to north. Ship A farther north is streaming west at 20 kilometers per hour and ship B is streaming north at 20 kilometers per hour. Okay. So we have a line from where to where? South to north. Okay, two ships are kept on that line only. Okay, on a line running south to north. What we observe, that ship A is moving further A farther north is streaming west at 20 km per hour. So A, which is at little bit farther away from B, is running towards west with the speed how much? 20 km per hour. While the B is streaming itself on the north with the speed how much? 20 km per hour. The question is simple. What is their distance of closest approach and how long do they take to reach it? Think ಮಾಡಿ solve ಮಾಡಿ ತುಂಬಾ easy problem. Ah. Can you solve this question, guys? Huh? Solve it fast. Solve very fast. My stomach is spinning, yaar. This is 8th class which I am taking. 8th number class. My throat is spinning in such a way now. I can't explain. Two zips A and B 10 km apart on a run. It is easy, guys. Okay. अच्छा छोटा सा little bit hint, not hint. Hmm. No, 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 no. अच्छा एक बात बताओ, चलो हितेश कुछ आइडिया दोगे इस क्वेश्चन पे? ये क्लोजेस्ट अप्रोच का कितना क्या मतलब हुआ? एनी आइडिया? राधा, परिणीता, अफन, कोई कुछ बोलो. दिस इज अ क्लास टू डिस्कस गाइस, यू डिस्कस प्लीज. हाँ हितेश टेल मी, यू आर टेलिंग समथिंग. हम्म. हितेश, अंकित कुछ आइडिया दोगे? Hypotenuse. But how come the hypotenuse will give you closer approach? See, oh, that is correct. Hypotenuse will draw, but how it is we have to say. अच्छा, निशांत, राधा, any idea? स्नेहा, कुछ idea दो इस क्वेश्चन के ऊपर? Any idea? अंकित, any idea? हितेश सही है, थोड़ा बहुत सही है, लेकिन उसे एक्सप्लेन नहीं करने आ रहा है. हितेश कुछ और बोलोगे इसके बारे में? I want to know your ideas just for this question. Yasmin, how did you calculate it? Mm-hmm. Velocity will be 20 root 2, correct? Mm-hmm. ओके सीरीज. अच्छा आ जाओ, चलो देखो तुम लोगों को सिखाता हूँ क्लोजेस्ट अप्रोच क्या होता है, ठीक है ना? देखो पहले पहले तो देखो भाई, सिंपल सी बात है. सबसे पहले सर हम क्या करेंगे, ये मेरे पास ए हुआ, ये मेरे पास बी हुआ, ठीक है ना? मैं क्या करता हूँ, सबसे पहला काम जो करता हूँ वो फाइंड करता हूँ कि what is the velocity of A with respect to B. So what I am doing, I am calculating velocity of A with respect to B over here, which is making angle theta over here. Got it or not? Yes or no? So what will be the velocity of A with respect to B? That will be what? Velocity of B plus velocity of A. Head is matching, tail is matching. That's why. Okay. Now, what is the angle between A and B? Now look over here. Between between CP, what is the angle? 90 degrees is the angle. Okay. So angle is how much? 90 degrees. So therefore, I can write that velocity of A and B, velocity of A with respect to B is nothing but it is equal to velocity of B square plus velocity of modulus of velocity of A square, which is equal to how much? 20 square plus 20 square, which is equal to how much? 20 root 2 kilometer per hour. This is my velocity of A with respect to B. Now, if I calculate velocity of A with respect to B, how much, like at what angles this is? This is at tan theta. Okay. With the vertical is how much? It is equal to perpendicular, which is 20 by base, which is equal to 20, which is equal to 1. And theta you got as what? 45 degree. So this is the basic calculation. Every small, even a normal person of the class will do like this way. Okay. So he will be able to do like this way. Okay. The question is, it is asking find the what is the distance of closest approach. Now, how to find the closest approach? The question is that. So let's suppose you try to understand. See, B is moving towards perpendicular direction. A is moving to B is moving towards vertical. A is moving opposite or like in the horizontal. So ये closest approach है क्या भाई? पहले ये बताओ मेरे को. Any idea? Distance into their angle. What is that? Mm-hmm. Perpendicular distance between which? Huh? Okay. So look over here. See, you are a little bit correct. So see this. This distance is given how much? 10 kilometers. Yes or no? Here, this is the velocity of A with respect to B. This is velocity of A. This is velocity of B. Now, the closest approach means what? It is the distance of, I'm writing closest approach. What is the meaning of that? First, you need to understand that. It is distance. What kind of distance? Closest it is. Now, closest means what? Minimum distance. Minimum distance of what thing? Minimum distance of what thing? Approach. Approach means what? A with respect to B now. So minimum distance of A with respect to what? With respect to B. Simple. Yes or no? Guys, is I have written a correct line or not? Tell me yes or no. It is yes, Win. Closest approach means what? Closest means minimum. Approach means what? Distance. So minimum distance between which things? Between CP and CP. Now, ship A is moving towards right, ship left, and ship B is moving towards up. And this is my velocity of A with respect to B. So therefore, the closest approach will happen in which direction? The closest approach will happen along the velocity direction. Simple. Now, so this is what? This is the direction of closest approach. Now try to see what is the distance of this closest approach, how to calculate, and I want to calculate this as a minimum. So what will be that? That simple. Look over here. If I draw one perpendicular from velocity of A, starting of velocity of A towards this velocity of AB, look over here. This particular perpendicular distance means this distance from here to here, from point O to point A will give you what? The closest approach, the minimum distance between A and B. Are you able to get me or not? Yes or no? Are you able to understand? Because at that time, the B will be over here, A will be over here, and this will be the distance of closest approach. Are you able to get me? This particular hypotenuse, which will be equal to this particular hypotenuse. Are you able to get me or not? See this? I'll draw it once again. This is हितेश समझ में आया ना अंकित निशांत क्वेश्चन अच्छे है ना ये सब क्वेश्चन मिलेंगे भी नहीं तुम्हें ठीक है तो देखो ये ए हो गया ठीक ये बी हो गया भाई साहब दिस इज वेलोसिटी ऑफ बी दिस इज वेलोसिटी ऑफ ए so after some time A will come over here and B will come over here. Yes or no? Now this particular distance will be the closest approach between them. So how to calculate this closest approach? In a simple way. Before going over here, what I did, I took one component. Okay, I took this as a component kind of thing, and I have drawn what I have drawn. I have drawn this as perpendicular over here. Okay, I will join it over here. Little bit kind of mismatch is there. So if I take it as a minimum, what you will observe that this diagonal, this particular diagonal is going to match with this diagonal, and therefore the minimum distance of this approach is what? The perpendicular of velocity of A with respect to B from the point A. Are you able to get me or not? Yes or no? So how to calculate this? This is 10. This is angle is how much? 45. So A's minimum is nothing but it is equal to what? OA, and that is equal to how much? It is equal to distance between A and B. Okay. How much? Sine 45 degree. Angle is how much? 45. So sine 45. So this is how much? Distance between A and B is how much? 10. Sine 45 is what? 1 by root 2. So 10 by root 2 kilometer is your distance of closest approach. Are you able to get me or not? Yes or no? Are you able to understand? ತುಂಬಾ ಚೆನ್ನಾಗಿದೆ question na? Radha, are you here? Nizan, Sanjana? Yes, sir. Okay. So that's why I told today is the very good class I'll take, because I was in the mood of taking class. Okay. So now look over here. What it is asking, how long do they take to reach it? So that is, now A will come over here in some time t. B will also come over here in some time t. So therefore, what is this path will also take how much? Similar time. So the time to this closest approach is how much? Is equal to distance minimum divided by, I think it will be distance minimum only, no? Yes or no? Yes, sir. It will be distance minimum only, no? No, wait. No, no, no. Yeah. So distance of this closest approach is how much? It is equal to what it is asking, how long they to make it. No, wait. Distance minimum. Wait. How long do they take to reach it? Okay. Okay, wait. Okay. That is also kind of correct. So distance minimum you can utilize, or you can also take this as length. Okay. So actually in book, if you will follow, so this length they have considered, but it is correct now. So look over it. This is in time t. This length is in time t. This is length is also in time t. So what will happen? You can bring this parallel line over here or not. Tell me yes or no. So this you can also consider. I consider this as velocity, this particular length. Okay, or I consider this as length, it will be also similar. So therefore distance minimum is what I'll consider from here to here, OB divided by what? Velocity of A with respect to B. That is again going to be how much? 10 by root 2 divided by velocity of A with respect to B is how much? 20 root 2, and that is, if you will calculate, it is equal to how much? Root 2 got cancelled. No, it will become, sorry. 2, it will become 2. So therefore it is 1 by 4 hours. Got it or not? 1 by 4 hours means how much minutes? 15 minutes. Are you able to get me or not? Yes or no? Okay. It was a hard question. No ना? अंकित समझ में आया ना? अफान समझ में आया? अफान सो गया. निशांत समझ में आया? निशांत, is it okay? राधा okay? राधा, is it okay? Sanjana okay? Now, do you want to solve more? Those who want to solve more, still there are questions. Okay, see these kind of questions. What kind of questions I have included? I'm going to make you guys topper. Yeah, ultimately, if you follow me properly, if you revise the things properly, I do everything for you guys. But except one guy, no one is revising. Okay. Okay. So we'll end up the class over here. Right or not?